I'm Katyora. Still kind of technically a graduate electrical engineer, and basically today what I'll be talking about is what role is technology going to play within our industry. So to just give a brief outline of my presentation, so I'm one of those people who's very pedantic and I kind of want to go my own way. So my presentation is kind of different. So we're going to look at Africa in context, what is currently happening within our continent, not just in South Africa. And then we're going to look at the Industrial 4.0. And then we're going to also then look at the disruptors versus the industry. And then incorporating storytelling to everything. And then the last one, the role of the radical young professional. So you will understand why I intentionally selected the word radical, because a lot of what's happening currently as a continent, we're actually behind with respect to the other continents. So if we put Africa in context, because I'm an electrical engineer, so the vast knowledge that I have is from the power sector. The continent is currently starved for electricity, as its power sector is significantly underdeveloped. So we don't have proper infrastructure from transmission lines and substations. So you'd actually see that the rate of electrification within Africa is less than 30%. So 30% of people in Africa actually have access to electricity. And then if we then look at the current major problems that are there, we have obviously poor governance, corruption, unemployment, and increasing population growth. So an interesting fact here with the increasing population growth is that as the population is going to increase, that means the demand for electricity is going to increase. So that less than 30% of the population that has access to electricity will require more and more energy, which currently our grid within the continent cannot sustain. And then obviously we do have the droughts and famine. And there was a report that was done by the World Bank that estimates that for the continent to have access to electricity for every single citizen, they would need about $490 billion worth of investments within for new generation capacity. So projects like you're building new power plants and renewable energy, and then about an additional $345 billion for transmission and distribution. So once you have your power plants, how do you then distribute that power throughout your different citizens? And then now, if we were to look at the Industrial 4.0, with the first industrial revolution, we looked at the mechanization, water power, and steam power. And then we moved to mass production in the assembly line. I think we all know about the Ford assembly model. And then the third industrial revolution, which is where we currently are, or currently moving out of, where we saw computers and automation. And then fourth industrial revolution. So here we're basically now talking about cyber physical systems. So we're now talking about your data, cloud storage, and the internet. So essentially, according to a study done by GE, they are estimating that by 2030, over 50 billion devices will be connected to the internet globally. So that kind of then becomes sort of like a game changer to how our day-to-day lives are going to change. And then now, if we're not looking at the innovation wave that has been happening, we're currently sitting here where we have have now your digital networks and your more focused ICT projects. And then from there, we're going to move to where we're going to go to renewable energy and then green energy and nanotechnology in order to sort of like achieve sustainability. But what is innovation? I think we like to throw that word a lot without actually understanding what it means. Well, in essence, innovation will require transformation. So innovation is transformation. Innovation means to change, but to change for the better. And the elements of that disruptive innovation, we're now looking at low cost, innovative business models. So from all sectors, whether it's power, whether it's construction, it's to now redesigning business models which now incorporate innovation. We're looking at sophisticated technology that simplifies. We're also looking at economically coherent value networks. And then the last one, regulations and standards that facilitate change. Because I think what generally happens is that we have countries like Ethiopia, which funny enough is actually the fastest growing economy in the world. We then have Rwanda, which is the most desirable investment country currently. So these are countries that are developing at a faster rate than a lot of the countries within the continent, actually overtaking your countries like Nigeria and Angola. And what will happen with that is that Ethiopia has the construction of what they're calling the Renaissance Hydropower plant. If that hydropower plant is going to be done, it's going to be producing twice as much power as what ESCOM produces. So Kusile, Medupi, everything. Ethiopia will be producing twice as much, and because it's hydro, it's going to be much cheaper. It's going to be much cheaper. Then on the other side, we're going to have DRC with the Grand Inga, who are going to be probably producing 3 times greater the amount of power that ESCOM is producing. So already, if we're now looking at a lower electrification rates within the continent, that actually then means that these countries can be able to also sell that power. So then there's now a need of regulation and standards that actually then facilitates change. And to be able to do that, we actually need to look at innovative solutions. And then if you're not looking at the power sector, because I think this is where sort of like my niche, the current technological changes that are happening, we have the first one, which is the Internet of Things. So the Internet of Things generally means that everything connected on the internet, whether it's data, whether it's information, accessing that information sharing between different parties. We have blockchain. I think also with blockchain, a lot of the people talk about blockchain and then they think Bitcoin. Blockchain has so much potential, which I will then show right now. And not just on the power sector, but also civil sector. I don't know much about the civil, but I'm hoping you guys won't shoot me for some of the suggestions that I'm going to make. And then embedded generation. So we're looking at lower rates of electrification. What does that mean? Have people produce their own power, solar rooftop PV panels. So this is where embedded generation is going to come in. And then we have battery storage. So if people can actually produce their own power, they need to store it. And if from storing, then that allows them to sell it back to ESCOM. And from selling it back, that kind of then generates business, not just within ESCOM, but also for the customers. And then if we're looking at the Internet of Things, basically what the Internet of Things is, you have different equipment, infrastructure, or devices where you then install sensors. And then from those sensors, they will capture the data. But when that data is captured, it needs to be sent somewhere. So when we're sending somewhere, we're sending it somewhere where it's going to be stored and analyzed. And once you have it there, that's where you can be able to do AI, artificial intelligence, be able to come up with algorithms and big data analytics. And then we get here where we talk now of the data value, where we can be able to now know more information, create better solutions, and whatnot. And then blockchain. What is blockchain? So in a very simple, because I know a lot of you are civil engineers and you guys hate programming and software. I don't know why, but anyway. So blockchain, imagine Yanko has something that I want. So I want Yanko's phone and I want to buy Yanko's phone. But Yanko was renting it to Islamulo. If I want to buy that phone, right, I need to be able to know more information about the phone that I'm buying from Yanko, right? So within a blockchain network, I can be able to then trace that entire information in a secure network. So that's essentially, in a very simple form, what blockchain is all about. But now what they are then doing it, which is why it's very popular within the finance industry, is that they're now looking in terms of cryptocurrency, which is a digital currency, which makes it very secure and very safe to be able to be moved digitally on the internet. And what enables it? So we're looking at a creation and real-time movement of digital assets. We're also looking at time-stamping, rights and ownership proofs. So like I said, I can actually be able to see who was using that phone before me and what changes were made on that phone. And then we also, if I can, running decentralized services. So in terms of, well, there's now the big talk of ESCOM. How if you look at the energy market, we have ESCOM as the big monopoly, and they're the only competition. So in a network like that, if we are to disbundle ESCOM to separate it from generation, distribution and transmission and give generation to private sector, you now have a network of different power producers that will allow then the customer to buy power from whoever you want to buy from. So a blockchain network will allow myself to be able to say, if I want to buy cheaper power, I can buy it from AB Holdings, who are producing solar at a PV plant that is probably nearer where I stay. And then its impact, it's going to re-engineer processes. There's going to be new flows of value, decentralized governance, new legal and regulatory frameworks. Because the nice thing about blockchain is that it's very secure. So it actually would take a professional hacker on average 10 years to hack into a blockchain network. So mind you, a software system is always being changed regularly. So by the time they get to the 10 years, the system gets changed, the coding gets changed, the algorithm has changed. And then some of the industries who are going to be affected by blockchain are the financial services, government services, healthcare, energy markets, supply chains, smart things, and world trade. And the reason why I put this slide is because if you look at these industries, in America, they actually implement it here. They're actually implementing blockchain. And funny enough, in South Africa, all of the banks actually implement blockchain. The transaction that you guys do with your apps, mobile banking and whatnot, there's an element of blockchain that is actually used, which is why you're able to, why they sell you the whole your money safe with them. And then we have government services who are actually implementing blockchain in terms of monitoring the infrastructure and whatnot. And then obviously the energy markets. And just in summary with blockchain, blockchain will allow optimization, so high availability, it's very cost saving in terms of speed, and then simplification. And then if you look now at the power sector in terms of the blockchain, Internet of Things, embedded generation and whatnot that I've mentioned, this is essentially what the future will look like. So So we have here where we're going to start having drones, which will be taking 3D imagery on network assets, which will enable engineers to diagnose the cause and point of failure remotely. And then from there, we have IoT sensors that will be able to monitor some of the assets within our grid. And then if we move a little bit into the residential areas, we're gonna start having smart meters. So the Joburg people, you should know about the City Power project, where they installed smart meters that actually automatically switch off your geyser once they see that your electricity consumption is getting high.